In this video, we're going to be talking about solving linear systems of equations and answering the question, is it possible for there to be no solutions or infinitely many solutions? So we're going to be doing quite a few examples where we're going to solve the system of equations and determine how many solutions it has. So in our first example here for letter A, we have x plus 3y equals 6 and negative x minus 3y equals 3. So we can see that our x's are already matching opposites, so we can go straight into adding these together. So we can add them together, and we're going to see that our x's cancel out, but so do our y's. And that's going to leave us with a 0 equals 9. It's kind of different, because we need to ask ourselves, when we have just a number equaling a number, is it true? Is it true that 0 equals 9? And the answer there is no, it's not true. And so this is going to give us no solution. So it is possible to have a system of equations come out with no solution, that these lines, these functions, never intersect. Let's take a look at letter B. Here we have 6x plus 6y equals negative 3, and we have negative 6x minus 6y equals 3. We have matching opposites for the x's, so we can go straight into adding these. When we do so, the x's cancel out, but so do the y's. And that leaves us with 0 equals 0. So again, we have a number equaling a number, so we need to ask ourselves if that's true. Is it true that 0 equals 0? And the answer is yes. And so here we have infinite solutions. So we see in situations where we can have no solutions, and in a situation where we can see we have infinite solutions. So it is possible. Let's go on to letter C. Here we have 2x minus 5y equals negative 3 and 3x plus 5y equals 8. Our x's are not matching opposites, but our y's are. So we can go straight into adding these. So we're going to go ahead and add them, and that's going to cross out our y's, and we're left with 5x equals 5. If we finish solving from there, we'll divide both sides by 5 to get x equals 1. Now we need to take that one and plug it back into either our top equation or our bottom equation, whichever one you want to work with. I'm going to choose to work with our bottom equation. I like that it's all positives. So I'm going to take that 3x plus 5y equals 8, and I'm going to replace the y with the number 1. Or excuse me, the x with the number 1, because we solved for x. The x is what we found. So we have 3 times 1 plus 5y equals 8. So we have 3 plus 5y equals 8. So now we want to solve for y, to get the y by itself. So we're going to subtract 3 from both sides, and that's going to give us 5y equals 5. Dividing 5 from both sides gives us y equals 1. So here, that gives us the ordered pair of 1, 1. When we plug them back into our top equation and our bottom equation, we're going to find that they both work. And so here, we've got one solution, which is 1, 1. These are the three types of answers you could have. You could have no solution for a system, infinitely many solutions for a system, or just one answer, which would be an ordered pair for a system. When you have just one answer for an ordered pair, you write the answer down. You don't just put there's one solution. So our answer of 1, 1 in part C would be correct. Let's take a look at a few more examples here. Let's go ahead and move it up so we have a little bit more room. So here we have 2x plus 3y equals 1 and negative 2x plus 3y equals negative 7. I'd like for you to give this one a try, so go ahead and push pause. When you're done, push play, and let's see if you were right. So because we have matching opposites for the x's, we're able to go just straight into adding these. And we're going to see that our x's cancel out. And that leaves us with 6y equals negative 6. So we'll divide both sides by 6 and get y equals a negative 1. So we have to decide which equation do we want to plug this into, top or the bottom. I'm going to choose the top equation. Again, I like the fact that everything in there was a positive. So I'm going to replace the y with the number negative 1, and then that's going to give us a 2x minus 3, not plus, minus 3 equals 1. So we'll add 3 to both sides to solve, and get 2x equals a 4. Divide both sides by 2 to get x equals a 2. So here we'll have an ordered pair of 2, comma, negative 1. Then again, that needs to be checked. So it needs to be plugged into our top equation and our bottom equation to see if it works. And in fact, it does. So here we have one solution as well. Now, if you forget how to plug that in and check it, you can always go back to the front of this playlist video and look at our video on solving systems by graphing, because there we go over, is this point a solution to the system? And that's basically how to check your solution. Problem E. Let's go ahead and have you do E and F actually on your own, and let's see how you do. So go ahead and push pause, work out E and F, and then when you're done, let's push play and let's see how you did. So here we see that we don't have matching x's or matching y's, but we know that a 4 can turn into an 8 really easy. So we're going to multiply everything by a 2. I'm going to do that, and that's going to give us a positive 8x plus 6y equals 34. Now, I don't need to rewrite my second equation. If I'm really careful, I can leave this second equation intact right there, because I can still add these together just like that, and that will still work. If you want to write both equations, you totally can. You would definitely be able to write that first equation, 8x plus 6y equals 34. Then underneath it, write the negative 8x minus 6y equals 34 as well. And then go from there. But we're going to start from here. So here I see that my x's cancel out, that's 0. And my y's are actually going to cancel out as well. So I'm going to have 0 equals 68. So we need to ask ourselves, because there's no variables, only numbers, is that true? Does 0 equal 68? And the answer there is no. So this should be a no solution. Taking a look at letter F, we see that our x's don't match and neither do our y's. So we're going to go ahead and we're going to multiply our top equation by a 3, because it's really easy for a 3 to become a 9. So we're going to multiply, and that's going to give us, to all three things, 9x minus 6y equals 18. And again, because I'm not doing anything to the bottom equation, I left it there and put my new top equation underneath it, because it saves me a little bit of time, which is always nice. So I'm going to go ahead and add those together. Then I'm going to cross out my 9's because those were supposed to eliminate, and they do. But my x's eliminate as well. So that's going to leave me with a 0 on the left side equals, and negative 18 plus 18 is also a 0. So here as we look, we ask ourselves, again because there are no variables, does 0 equal 0? And the answer is yes, 0 equals 0. So here we're going to have infinite solutions. Let's do just a few more examples. So for this next example, same thing. We have 5x plus 7y equals 7 and 7x plus 5y equals 5. Notice we don't have any matching x's or y's, so we're going to have to multiply. And we're going to have to multiply not just one equation, but both equations. So we're going to get rid of the x's here. So I want to know, what does 5 and 7 have in common? Now, if you can't think of what number they have in common, you can always just times the top equation by the bottom number and the bottom equation by the top number. So but they have the number 35 in common, which actually does just that. If we're going to multiply the top equation by a negative 7, we're going to multiply the bottom equation by a 5. So we made the negative on the 7 negative this time because we needed to make sure that the x's were going to be matching opposites, not just matching. So we'll distribute the negative 7 to everything in the top equation and the 5 to everything in our bottom equation. And that's going to give us, for our top equation, negative 35x minus 49y equals negative 49. By multiplying the 5 in the bottom equation, we get 35x plus 25y equals 25. So we'll go ahead and we'll add those together. Our x's are going to eliminate as we had hoped. When we add negative 49 plus 25, we get negative 24y, and negative 49 plus 25 is negative 24. We finish solving by dividing both sides by negative 24, and that's going to give us y equals 1. Then we need to plug our 1 back into either our top or our bottom equation. It doesn't matter which equation you choose, either one will give you your x value. So we're going to go ahead and we're going to plug this into our top equation. 5x plus 7y equals 7. We're going to replace the 7 with the 1, giving us 5x plus 7 equals 7. And we're going to solve for x, meaning we're going to subtract 7 from both sides, giving us 5x equals 0. Then we're going to divide both sides by 5 and get x equals 0. This gives us the solution 0, 1. And when we plug that back into both the top and bottom equations, we see that that works. If we take a look at letter B, we have y equals 2/3 x plus 7 and y equals 2/3 x minus 5. So here we're really close to having matching opposites. In fact, our y's already match. We just need one of them to be a negative. So we're going to go ahead and we're going to multiply our top equation here by a negative 1 and distribute that to all three things. So that's going to give me a negative y minus 2/3 x, or a negative 2/3 x minus 7. From there, we're able to add them together, and my y's are going to cancel out, giving me a 0 equals, and my x's are going to cancel out as well, and then a negative 12. Because our x and our y are both gone, now we need to ask ourselves, is this a true statement? Is 0 equal to negative 12? And that answer is no. And so this is going to be a no solution. If we take a look at letter C, we have negative 3x plus 5y equals 15, and 9x minus 15y equals negative 45. I'd like you to try this one on your own, so go ahead and push pause and work out the problem, and when you're done, push play, and let's see if you were right. So here, we're going to go ahead and make our x's match. So we're going to multiply our entire top equation. Ooh, not by 9, that'd be way too much, but by a 3, because 3 times 3 is 9. So we're going to go ahead and distribute that to all three pieces. That's going to give us a negative 9x plus 15y equals 45. To save time, I wrote it underneath my second equation that I didn't change. So I'm going to see that my x's cancel out, and oh, my y's are too. That's awesome. So I'm going to have 0 equals, and negative 45 plus 45 is also a 0. So again, because I don't have an x value or a y value, I need to know, is this a true statement? Does 0 equal 0? And that answer is yes. So here, our answer is infinite solutions. And it's completely acceptable to just put the infinity sign and box it as your solution there. So as we've seen from the last few examples we've done, it is possible to have no solution or infinitely many solutions or just one solution when we're dealing with a system of linear equations.